Okay, good evening, everyone. My name is Rob Maher. I'm with the Electrical and Computer Engineering Department at Montana State, and really delighted to be here this evening, and also to hear what the other speakers have to say. So really looking forward to it. So the outline of my talk today will be to talk a little bit about the research that we do in audio forensic analysis, and particularly gunshot acoustics. So I think the meeting organizers wanted to get this roadshow off with a bang, so they thought... So we'll describe some of the research that we do here and why we do it, and some of the background on that as we go along. So the first question probably is, what is audio forensic analysis? So the way you can think about this is the analysis of audio recordings, not so much for entertainment, but recordings that might end up in court. And so these are recordings that could be from a surveillance system or from a body camera, or they could be a cockpit voice recorder from an airliner accident, things like that need to be investigated. In audio forensics, there are three major concerns that people have. The first is authenticity. And hopefully none of you will be in court where there's audio evidence being presented. But if you should be in that situation, you certainly want to make sure that the audio is authentic and hasn't been edited either deliberately or inadvertently so that it isn't what it's being represented to be. The second concern is enhancement. There are often reasons that a surveillance recording or a recording from an accident or something like that might be of very poor quality. And so for a judge or for a jury to understand what's being said, it may be necessary to provide enhancement and noise reduction of that recording. And the third concern of audio forensics, which is the area I primarily work in, is interpretation and documentation. And this has to do with figuring out the timeline, the sequence of events, which event preceded another event, and then also the identity of the different sounds that might be present in that recording that are of importance to the investigation. Now, if you're really, really interested in this topic, and 10 minutes isn't enough, there's a book I wrote on this, and it's available at the MSU library or on Amazon. Okay, so for gunshot sounds, this is a picture of a recording, a forensic recording. Across the top is what an engineer would look at. This is time running along left to right, and then the wiggles here are indicating the sound pressure at every given instant. And in the bottom is a picture called a spectrogram, and this is a special kind of graph that has frequency along the vertical axis and time horizontally. And I've indicated manually several indications here that would be useful if this were being presented in court to explain to the jury what they're supposed to understand from the depiction. Now, the question might be, well, why would anyone care about gunshot acoustics? And this work is funded by the U.S. National Institute of Justice. And they are interested in this because in the United States, for instance, in 2017, there were more than 1 million assaults reported to the police. And 400,000 people were involved in a crime that involved a firearm. And so those people, the firearm may not have been discharged, but if it was, there's certainly a lot of concern about that. The other thing that's happened, as you probably know, is there's a very high likelihood nowadays that a law enforcement officer will have an audio recorder or a video recorder in the police cruiser or wearing a body camera. And so the amount of evidence that might be available in any situation is getting to be pretty high. So that's why the Department of Justice is interested in funding this work. So gunshot acoustics comes in two kinds. One is the real-time gunshot detection systems that are available and are certainly of interest to the military for sniper localization. The other kind is the forensic reconstruction, which is taking a recording days, weeks, months, years after the incident and then interpreting it. And that's the area that I'm working in primarily is the forensic interpretation. Gunshot sounds, as we all know, are loud. The report of the gun, the muzzle blast is very loud if you're near to it. What many people don't realize is it's also extremely short in duration. The muzzle blast only lasts 2 or 3 thousandths of a second. It's barely a pop. And often when we read ear witness testimony to a shooting, people will often report that it sounded like firecrackers. It didn't sound like a gun. It was just pop, 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 pop. And we are so accustomed to what we hear in movies and video games and TV, which is this very elaborate kind kind of sound, that actual gunshots are very, very short in duration, and we'll see some of that. The other thing I found from the research that surprised me was gunshot sounds are very directional, substantially louder out in front of the firearm than around to the side or behind. And that has impact on the interpretation of recordings that have a gunshot in them. And typical forensic recordings have a lot of echoes and reverberation due to sound reflections off the ground and nearby objects and things like that that need to be interpreted. Gunshot acoustical evidence can include the mechanical action of the firearm, the cocking mechanism, the trigger, ejection of spent cartridges, and those can be important for forensic interpretation. The muzzle blast, that's the bang of the gun. If the bullet that comes out of the gun is supersonic, which is true for rifles and some handguns, the bullet itself is a supersonic projectile. It makes a mini-sonic boom. And if the microphone is in the right position, it can actually pick up the sound that the bullet makes in addition to the bang of the gun. And we'll see that here in a second. So when we go to the laboratory to do gunshot recordings, this is kind of the situation that we're in. We have an array of microphones that we raise off the ground, and we have a shooting platform that's also raised. And we do this so that we can record the bang of the gun long before the first reflection arrives at the microphone. So we get what is called an anechoic recording, a no-echo recording, a very, very special kind of recording. So we set the microphones up on this arc, so the gun is shooting in this direction, and then we can get the sound in all directions simultaneously. So the marksman is then on the platform, and then we do the recording this way. So very, very specialized kind of thing that the National Institute of Justice is funding us to do. So if we look at a recording like this, here's a recording of a rifle shot for microphone 1. So we're out in front of the gun. The shooter is not hitting the microphone, but shooting close to it. And the recording then has that supersonic shockwave of the bullet whizzing by the microphone. So it makes a crack that's ahead of the sound of the muzzle blast or the bang of the gun that comes after that. And so all of this is over in just fractions, thousandths of a second is all that it takes for that pop to occur. If we look at that 308 rifle shot at angle 0, that's what we were just looking at. If we look at all the other angles off to the side and then around behind, we can see that the characteristic sound of the gun is quite different as we get to the back. And then if we compare a 9mm handgun, this is a Glock pistol, it has a different sound compared to the rifle, and then quite an elaborate, detailed sound off-axis due to the various vents and the mechanical action of that particular firearm. And so those are the distinctive features that we will get in our database. Now, in actual evidence for a research situation, here's a recording that had 5 different recordings of the same shooting incident from different vehicles, different officers that had body cameras. And so you can see some of these are clipped, meaning that the sound is so loud we don't even get a good waveform out of it. Some of these were inside the cabin of a police cruiser, and so we can get a better picture of those. So, wrapping up now, audio forensics is increasingly available, mostly because this technology is now out. If there's an incident, it's very common. People are whipping out their cell phone and their electronic news gathering on hand, and so the prevalence of the data is much greater than it was 10 or 20 years ago. Unfortunately, this kind of evidence can include gunshots, and it's important to be able to understand them, which is the contribution the university is making. These reference recordings show that there's a lot of complexity that we need to understand in interpreting this type of evidence, and much of our current research that's been funded is looking at how these sounds are picked up by body cameras and other devices like that. So I'd like to thank you for your attention and thank the VPR for putting on this event. And I also want to thank a couple colleagues, Steve Shaw from my department and a colleague from Brazil who came up and did some research on this, and then a group of our excellent students at MSU who have worked on this project. So thank you very much.